Morning, good afternoon, good evening, wherever you are in the world today. Welcome to today's webinar. And the topic today is on IEC 61511 compliance and how to get started. One of the reasons I did this was because in the classes and in talking to some of our clients, this question has come up a few times about, okay, it's all well and good being compliant, but how do we become compliant? And this is one of the questions that I often get asked. So I thought I'd put this together and see what interest we have. Now, it seems that we're still having some problems with audio. So nobody, can you all hear me? Okay, so some can, some can't. Okay, it looks like majority can hear me. Okay, so we'll keep going. So as I said, the subject is how to get started. And just by way of introduction, some of you may or may not know about Exeter. So I will just do a quick introduction on Exeter and who we are and what we do, just to bring you up to speed. So we're a company that focuses on three main areas when it comes to providing process safety support, and that is in terms of cybersecurity, functional safety, and alarm management, which are all closely linked, and we treat them as an integral part of process safety. And we've been providing support and solutions on the full life cycle for many clients now for a number of years, as well as providing the certification support on the product side and on the personnel side. So from the product point of view, we can do IEC 61508 product certification for functional safety, and now we're doing more IEC 62443-2-1 type certification for cybersecurity. So with these services, we have a comprehensive set of tools, and I'm sure some of you are using or have used the Excellencia suite, which we've recently introduced the version 4, which provides a much more comprehensive set of tools now to cover the full safety life cycle. And again, if any of you are interested in that, you can always let us know. In terms of our footprint, we are a global company. We have many offices around the world, and we also have just recently opened a subsidiary in India. So in Germany, for example, our German subsidiary covers the automotive primarily. In the US, we cover petrochemical, chemical, general oil and gas, and most other process industries. In South America, we've done both safety and alarm rationalization, as well as cybersecurity, and also in other parts of the world too. In terms of our success and how we measure that, we actually have, according to the ARC survey, 65% market share in terms of device certification that's done by Exeter versus anybody else. And we are primarily an employee-owned company, even though the company was originally started with 2 people. It's grown significantly since then. Now we have over 100 global consultants. We've done over 1,000 certification and assessments, and we've modeled well over 500,000 CFCs through the Excellencia tool. So we have a pretty substantial footprint. And this often surprises people because they don't tend to think of us in that way. In terms of reference materials, we've authored probably the most number of books on automation, safety, and reliability. And some of you may already have some of these books. If you sit and do the FSC 100 course, we do supply 3 of the books usually for supporting the course and helping people with their move towards becoming certified as a certified functional safety expert or a certified functional safety professional, and also from the cybersecurity side. These books are available through the website, and the SCRH, for example, that's shown here is the Safe Equipment Reliability Handbook. There's a 4th volume that's coming out. These contain all the failure rates of most types of equipment that you would find in process safety applications. This, of course, is the database that is built into the Excellencia tool, which makes it very, very powerful. And these books are available through the website. We have a new cybersecurity book that's coming out. We've just recently published a final elements book. So these are coming out regularly, and through the Exeter website, you can get access to a lot of free material. These webinars, for example, are all recorded, and they're available through the resources tabs. There are papers, white papers, and lots of other free material that's available. So I always encourage people to avail those resources and make best use of them. A little bit about me. Those of you that don't know me, I've been around in industry for over 40 years now, and I teach. One of the other things I do is I teach the FSC 100 course, one of the primary instructors for that. And I've written a number of papers and do blogs and webinars and speak at conferences, etc. Okay, so let's get to the meat of this webinar today, which is compliance. How do we get started? And some people think that trying to be compliant with 61511 is going to cost them a fortune to get into it and get going, and sometimes it's very difficult to see the wood for the trees because they don't know where to start, and this is where confusion comes. Now, the reason that compliance is necessary, of course, is that if you come under either OSHA in the US, PSM for process safety, or COMAH in the UK, then you are required to follow what is known as best practice. So what is best practice? Well, the IEC61511 or the ISA S84 is recognized as being RAGAGEP or best practice by OSHA and COMAH, and that's recognized and generally accepted good engineering practice. That's a term that's been around in industry for a long time, and it means all sorts of things to different people. But generally speaking, if you're following best practice, that's the best you can do right now. And so if you do that and you have an incident, because again, there's no such thing as zero risk. There's always going to be some finite risk. And if you do, and you follow best practice, well, that's the best you can do. And as long as the prosecution can't prove negligence, then you've done as best you can. And with the 1511 and the S84, it's based upon what we call a safety life cycle. So the safety life cycle primarily splits into 3 phases. The analysis phase is where we do our risk and hazard analysis. What are the hazards that are posed by our process? What are the possible consequences and the severity of those consequences? And what current protection do we have in place to help us prevent this from happening? And what we do during analysis is we look at our tolerable risk. What are we prepared to accept in terms of the boundaries as identified through the ALARP, as low as reasonably practicable principle? And as long as we fit within that, we then look at what layers of protection we have, and any gaps in that will determine how we plug those gaps in terms of whether we put a safety instrumented system with safety instrumented functions at specific risk reduction targets, or we use other means. And from analysis, then we end up with a requirements specification for any safety instrumented systems and CFCs. And that then leads us into the design and implementation, where we then look at how we are going to achieve that additional risk reduction using safety instrumented functions, and also what level of risk reduction we expect or we need to achieve. From there, we move into operation and maintenance. So this is where we spend most of our time during the lifetime of the SIS. Now, there's an old adage that talks about 20-20-20, sometimes known as the 20-20 rule. And this is where you spend roughly 20 weeks during the design and analysis cycle, and then you spend 20 months in implementation, and then 20 years in operation. So from the point of view of the life cycle, the majority of the time we're going to be spending in operation and maintenance. So it's very important that we identify what we need to do to maintain the integrity of our safety instrumented system and its CFCs. And if we follow the life cycle properly, which is a sequential life cycle, meaning that we go through predetermined steps, then what we will achieve is a balance between the risk performance, the amount of risk reduction we're aiming to achieve, with the design and the cost. And we balance it out. And if we do it right, we are actually in the long run save money. So this is the purpose of the safety life cycle. It's there to give us consistency in terms of how we approach looking at designing, implementing, and operating a safety instrumented system to achieve our goal of risk reduction. So the life cycle then requires us, from the IEC 61511 point of view, to be compliant with the following clauses. So the first one is management of functional safety. So this really is, how are we going to manage doing or achieving functional safety throughout the safety life cycle? And this is very important. Then clause 6 covers the life cycle requirements itself in terms of the 3 phases. Clause 7 talks about verification. How are we going to verify, and in other words, how are we going to test at each particular phase and each particular activity that we meet requirement. Clause 8 covers our process hazard and risk assessments and analysis. It's very important. We need to know what hazards we have present, because if we get this wrong, then we could end up with basically understating the risk. Clause 9 covers the allocation of safety functions to protection layers and this requirement for independence. Clause 10 talks about the safety requirement specification and what needs to be considered. And then clause 11 deals with the design and engineering. How are we going to design and engineer? Are we going to be using third parties? And this would be covered as part of our functional safety management plan. Clause 12, the application development. If we're going to be using a safety instrumented system with logic solvers, how are we going to program those? So application development is very important. What languages are we going to be applying? Clause 13 talks about a factory acceptance test. This is where we would bring the application software together with the logic solver for the first time. And then clause 14 covers installation and commissioning. How are we going to install it? How are we going to commission it? And once we've done that, then we have to validate. In other words, we have to make sure that the SIS, as it's installed and commissioned with its CFCs, meet all the requirements of the SRS, including timing. So we need to be able to prove that. Clause 16 covers the operation and maintenance. And as I've said, this is where we'll be spending 90% or more of our time during the SIS normal life. Clause 17 covers modification. And so we have to talk about how we're going to control modification. The management of change is very important. And then clause 18 in terms of the decommissioning. Once we're getting to the end of the life of the SIS, how are we going to decommission? And then clause 19 covers the information and documentation requirements. So to be compliant, we have to meet these clauses. So if we look at the safety life cycle, we can see the three phases. There's the analysis, there's the design and implementation, and the operation. And you can see that what governs it is the management of functional safety and safety life cycle structure and planning. So we have to make sure that our documentation and our process is well defined. In support of that is the verification done at each of the particular stages, and then the relevant functional safety assessments, where we are looking to make sure we've met our safety targets for each of those particular phases. And you'll see that some are in green and some are in red. Depending upon how you interpret the requirements in the standard, you would have to do an FSA 3. But when you do an FSA 3, if you haven't done FSA 1 and 2, you need to make sure that the scope of those two FSAs are also covered under FSA 3. So you may as well do FSA 1 and 2. FSA 4, the Functional Safety Assessment 4, is to make sure that we're doing our periodic performance analysis. So we should be gathering information from site in terms of proof testing results, any failures, any potential trips, any real trips. All of that data needs to be recorded. And then we have to, if we're going to make any modifications, we have to do an FSA 5, which means we have to assess the impact on safety. So these are requirements to support the activities during the safety life cycle. So with all that being said, how do we get started? So this is where we take a pragmatic approach. And the first place to start is with what we call a simple GAAP. So this would be a GAAP review of any existing system in place for documentation for managing safety and managing the development of an SIS. So this is a fairly low investment because usually the GAAP can be performed in 2 or 3 days. And the point here is that what we're looking at is how can we leverage the existing quality system. So most companies will have some form of ISO 9000 quality system in place. OSHA requires them to have that anyway. So we can look at that, we can identify against that existing quality system any gaps in terms of processes and procedures that need to be filled in to meet the requirement of 61511. And typically, most companies have a lot of the elements required to meet the functional safety management requirements, but they don't actually have anything called a functional safety management plan. So that's a fairly easy thing to rectify. And then what we do from that is we can create a roadmap of how to achieve compliance once we've identified those gaps, and we can then look at, okay, how do we fill them and how long or over what time period do we want to do that? And the point is that Rome wasn't built in a day. So obviously we don't have to do everything from day one. What we can do is outline a plan of implementation. So this is a pragmatic approach. So we use the results, we can look at how we can fix or come up with solutions, we can look at opportunities to save money, and then we can look at prioritization. So what are the key requirements? In terms of the functional safety management plan, we need to define roles and responsibilities. This is something that's been added into the 2016 requirement for 61511. So there's much more emphasis now on defining roles and responsibilities, because clearly there have been instances where people haven't been sure what their role or what their responsibility is. So we need to define that. So there needs to be a procedure in place to define roles and responsibilities. Then we need to define how functional safety is going to be carried out. We may be using a mix of internal resources, we may be using external resources. So we need to define that, and we need to define how we're going to control that. Then, of course, there needs to be a well-defined set of procedures and references to existing procedures. Like I said, If there's already the quality system, we've already got procedures in place, they're being followed, then we can take credit for that and we can utilize that and we can reference them. So the functional safety management plan could reference existing policies and procedures that are already in place. We can create competency records and assessments. Here again, this is another major requirement of the 1511, is competency. So not just defining roles and responsibilities, but making sure that the people in those roles with those responsibilities are competent to do that. So competency and assessments is very important. 1511 requires the periodic, doesn't define how often that is, assessment, ongoing assessment of our personnel. And then conduct functional safety audits and assessments. So in this essence, the GAAP analysis would be the first functional safety audit. And that was where you can start. And then we need to make sure we're covering all the SIS design activities, not just the hardware design, but also the application software design. And we verify and validate the SIS design. So part of functional safety management is having procedures in place for being able to do this verification and validation. And here again, we might be using independent third parties. There is a requirement to make sure that we have sufficient independence when it comes to conducting functional safety assessments and audits, but also doing validation. And then we have to measure performance. Remember, 61511 is a performance-based standard. A performance-based standard says this is what you have to do, but doesn't define how you do it. However, you need to have some key performance indicators to be able to measure performance such that you can compare it to the original design requirements that are specified in the SRS to see, are we meeting those requirements or are we exceeding those requirements? And then we have to carry out mechanical integrity and maintenance. Remembering throughout the operation and maintenance phase of the life cycle, which can be 15 to 20 years, we have to make sure we follow the manufacturer's useful life recommendations. And we have to make sure that we have a plan in place to change out equipment as it comes to the end of useful life. So there needs to be mechanical integrity and maintenance. And the implementing management of change. We need to have controls, administrative controls and procedures in place to be able to handle management of change. And here again, if the company already has an ISO 9000 system in place, part of that will be covered under management of change. So what documents do we need to generate? Well, basically any information relating to each phase of the safety life cycle. There are inputs and there are outputs, and the outputs will be documentation required to be able to verify and prove that we've followed everything in that phase. We have to have management of functional safety, so we have to have a means for tracking and auditing. We have to have documentation that proves we've verified and validated, and we've performed functional safety assessments. The thing to remember here is I call it the 4 R's, which is the right data at the right format, because that's usually another issue sometimes when moving between one interface to another, at the right time, timeliness, making sure we have the right information at the right time, and of course the right place, making sure it's delivered where it needs to be delivered. If that's not electronically, then it has to be physically. And this refers to making sure that the SRS flows through to the operations and maintenance people, because they need to know what performance targets there are for each of the SIFs in the SRS. So how do we perform a GAAP assessment? Well, it's a very simple 2-stage process that we go through. We can do a back office paper review. Typically, if documentation exists, policies or procedures exist that are in Word or PDF format, they're easily searchable, then As long as the documentation is available, we can usually go through it fairly quickly, and we issue a published report identifying any particular gaps, together with recommendations on how to fill those gaps. And as I've said, depending upon level of documentation and complexity, it's usually achieved within 2 or 3 days. This means then that companies or the O&M people can use the OPEX budget to cover this cost, because it's going to be less than $10,000. And the report itself can be used to help justify any additional spend with management, because now you have an independent report that says, here's where we're compliant, here's where we're not compliant, this is what we need to do to fill the gaps. And as I said, we can look at phasing it. So you could say, all right, we are going to make sure that within the next 18 months we're compliant. That's fine. Then you can look at what that requires within that 18-month time frame and budget for it. We can also then set priorities. So you can set the priorities based upon where are the significant gaps or the most important gaps that need to be fixed. You could also use it to maybe focus on what we call the low-hanging fruit. So for example, if competency records are missing, that can be done fairly easily. Any training requirements can be filled fairly easily. So again, you can use the report to help you identify where you need to focus your attention first, and also help agree a budget with management. Now here, this will very much depend upon culture. And those of you that have been on some of my webinars before have heard me talk about the importance of having the right culture, because culture comes from top management, and if the right safety culture is in place, then getting agreement on spending to improve or to fix some of the gaps shouldn't be too much of an issue. From that, we can create a plan and set milestones. So we can map out what it is we're going to do over what period of time, and where are the key milestone points that we can use to provide visibility to management on progress, and also for maybe major budget spending points. And then, as I've said, we can design and implement in phases. So the way we would approach this is, as you would approach any project, we would assign somebody who's responsible, call him a project manager, making sure that he is accountable, he or she for that matter, and then track progress against the milestones. So if things are going awry, then we should be able to see that fairly quickly, and corrective action can be taken. It then provides visibility to management, so you can provide regular updates, and you can use independent third parties to do the auditing or to do the functional safety assessments. Just makes things easier and cleaner, because the impartiality and independence is clear. And that is one of the requirements for performing a functional safety assessment. So the benefits of treating it as a project, of course, is that we have a visible plan. So if, for example, the auditor happens to come calling, you can show that there is a plan in place, that you are making progress and you're moving towards compliance. This is very useful. It also provides us with a low-cost means of establishing our benchmark. By doing that initial gap, which is fairly low cost, we can see where we're starting from. And remember, the point here is we're not going to reinvent the wheel. We're going to leverage our existing quality system and the procedures that we already have, that we're following. It then enables us to provide this prioritization on the gaps and what we need to do in terms of remediation, and how we're going to do the remediation. Here again, it may be a combination of using internal resources and external resources. By doing this, we have the ability now to manage funding and then to deal with it in phases, as I've already said. So all of this is very good in terms of being able to track, to be able to provide visibility to management, to be able to monitor and control costs, and do it according to the company's budgeting program, when their fiscal year ends, when it begins, etc., as well as being able to track our progress. Okay, so that's typically the approach that would be taken to getting things going, to starting the process. Fairly quick and easy GAAP, looking at the established existing quality systems with procedures in place, and then identifying additional procedures if needed, or changes to existing procedures, identifying a need for a functional safety management plan if it doesn't exist. So all of that can be done fairly easily. And then you can look at what needs to be done, look at the phasing, look at the quick wins with putting in, for example, if there are no roles and responsibilities defined, we can do that fairly easily, and looking at a competency matrix and training plan. So we don't need to do it in one go, we can phase it. The purpose of that initial gap is that we get visibility. So we can go to management with a report and findings and say, okay, it's not as bad as we thought, here are the gaps, this is what we can do. And we've done that with a number of clients where we've gone in, it's not as bad as they first thought. We've also had clients where we've gone in and it has been fairly significant, but we've managed to phase it out over an 18-month to 2-year period, which was acceptable to management. It was manageable in terms of budget and costing. And so it was easy to handle. Those existing procedures will not be wasted. We would leverage what we currently have. That's the primary benefit of doing this gap, is to look at what do we currently have in place, what can we utilize, and refer to those. So for example, if we have a lot of the procedures already existing, but we actually don't have a functional safety management plan per se, we can create a document that refers to the existing procedures. So we have a functional safety management plan, a document that covers that. We can show that to any auditors. We can refer to the relevant procedures. We have evidence that those procedures are being followed and are working. And so we have visibility. We can use this to help us prioritize our gaps as well. So if we do have a significant gap that has an implication, then we can look at how we fill that first. So we can help prioritize, and this is where we generate our plan based upon our priorities. And phasing it so that we can look at how we're going to budget, how we're going to spend, how it's going to be controlled, how is it going to be reported, etc. And then we can monitor the progress against these milestones. So part of the plan would be to set up milestones, providing visibility to management. And as I've said already, if the auditor comes calling, you have something you can show them. You can show visibility, you have visibility, you can show progress and evidence that you're working towards that. So these are all big positives. So what we get out of this ultimately is a functional safety management plan, which is the first requirement for compliance with 1511. We will meet clause 5. So we make sure then that we have the required procedures that address all 3 life cycle phases. In terms of the analysis, how do we do the analysis? Do we have third parties come in to facilitate our PHAs, for example, and our LOPAs? Do we use existing resources? Are they competent? And again, we have our roles and responsibilities defined and our competency matrix in place. If they're not competent, then we should be looking at using competent people or going to a third party that also needs to prove they're competent to do the work. So competency is very important, and the whole point of functional safety management, if those of you that have been on my course before or heard previous webinars, I always talk about the 3 Ps for managing systematic. And functional safety management is all about managing systematic failures. And the 3 Ps associated with systematic, of course, are our personnel. Are they properly trained and competent to do what they're doing? The second one is processes and procedures. Do we have well-defined processes and procedures in place that are being followed? And we have evidence to that effect. And then the third one, of course, is paperwork. Do we have a paper trail that we can show auditors and we can prove that we're following and doing the things we say we're doing? So that's the purpose of functional safety management, and that's why we have the assessments and the audits. So that would be the goal. End up with a functional safety management plan that addresses the safety life cycle. Okay, so I will now hand it over to questions, see if there's any questions. Okay, what do we have here? We have quite a few questions, that's good. We usually, the question is, will a copy of this slide set be available? We do make them available as PDFs, and again, this webinar is recorded, so they're available too. Normally, EPCs are involved in FSA 1 through FSA 2 and 3. How the ownership is transferred and what responsibility EPC safety engineers carries afterwards. Yes, well, again, the EPC's role is to make sure that they're designing the system to the SRS. And again, depending on who's created the SRS, once you've completed and handed over after FSA 3, it becomes the responsibility of the end user to follow clause 16 for the operations and maintenance. As long as you've done your job and the FSA 3 shows that the validation of the SRS to the installed and commissioned SIS, then your responsibility ends with the transfer across to the end user. How do you handle independency if you help an organization to get certified and you also... Well, it depends what you mean by certified. You see, again, people throw this term around. If you recall, the reason why we have functional safety assessments and functional safety audits for the against 61511 is because we don't certify 1511. The manufacturers have certification for products, so they are certified, their products are certified, and part of the manufacturing certification is to look at their systematic issues in terms of having the right people trained, having all the procedures in place, making sure design reviews are done properly, making sure that testing is done properly, the documentation is all done properly. When it comes to the end users, it's more difficult to do that. So we would do functional safety assessments. Now, for the engineering companies, we can review their functional safety management plan and program to make sure it's compliant with 61511. So we can attest to the compliancy. So you've got to be careful when you throw the word certification around. Independence means that you have to prove sufficient independence from the design if it's the design phase. The same with the analysis. So the same people cannot do the assessments if they've been involved in the design. That's why a lot of times people will use third parties because they're truly independent. Some of the larger companies will use different groups that weren't involved in the design to do the assessments. As long as they again meet the requirement for 1511 competency, then that's fine. What is a good source of useful life data if it's not available from the manufacturer? Well, this is where we've been involved doing FMEDAs, because the FMEDA can give you a useful life number. We can generate that from doing a FMEDA, and that's usually what happens. That's part of the proven in use, of course. As we go through proven in use, is you do, depending upon the data that's available, you would use FMEDA to substantiate that. But if it's a certified device, the requirement is that the safety manual now has to include the useful life. And that's been in there since the 2010 1508 change. So manufacturers should by now have included useful life in safety manuals. Does IEC 61511 apply to alarm management? Alarm management is covered specifically under ISA 182. Now, of course, alarms are an important part, especially if you're claiming, and here's where we get into the independence argument, when companies are claiming for alarms and they're claiming for their BPCS. Now, if the alarms are being generated by the BPCS, then you cannot claim independence. So you would have to treat that as one safety layer. So 1511 is very specific about independence. So 1511 talks about the independence, but alarm management is covered specifically under the ISA 182, and I forget what the IEC equivalent of that is. We always talk about certifying a product or a process. Is there such a thing as certifying a plant or site? No. What you could do, again, this use of the term certification, what we would do is we can assess how well the end user complies with 1511. And that's why we have functional safety assessments. So functional safety assessment 4 is where we would look at the periodic review. And of course, functional safety audits would make sure that we're following through on what we're supposed to be doing in terms of, are we doing proof testing on time? Are we recording the results? So part of FSA 4 is to look at doing this periodic review. Again, the standard says periodic. It doesn't say when. And most of the time you could use the 5-year window between doing PHAs, because if you haven't had any incidences, but you've been doing your proof testing, you've been doing your maintenance, you've been recording data, then that's a useful period of time, because you can use the assessment to feed into the PHA team, just to make sure that there have been no changes, or if things have been better than you thought, first of all, then you can maybe modify. And that's where the balancing comes in with the safety life cycle and cost. Because obviously, if our performance is much better than we originally envisaged or designed, we can maybe start backing off on a few things, like maybe stretching the proof test interval a bit more to save money on doing the proof testing. Somebody's asking me for a follow-up webinar, case studies webinar. That's a good point. Any particular case studies, let me know. I'd be happy to look at that. We have many. Who overlooks Exeter? In other words, Exeter certifies products and who overlooks? We are ANSI accredited. So that's a good question. Who certifies the certifier? So there's a body called the International Accreditation Forum, the IAF, which most countries in the world are members of, and they nominate an organization to act as what's known as the accreditation body. And the accreditation body is responsible for monitoring and certifying certification bodies. So we are, in North America, ANSI is the accreditation body, and we are a certification body. So ANSI audits us 2 or 3 times a year to make sure that we're following the requirements for doing certification, which I believe is IEC61511 is one of them. So that's how, and on an Exeter certificate, you will always see in the left-hand bottom corner the ANSI symbol. So when you look at a certificate from a so-called certification agency, if you do not see an accreditation body logo on the certificate, then you should be pushing back to say who is your assessment body. because otherwise it could be they're doing it in-house and they're not really accredited to do the work. So it's a very good question, and that's what you have to look at. Do we have a standard GAAP checklist so that comprehensive GAAP assessment can be done? Yes, we do, and that's what you pay us for. During the conceptual basic design phase, what are the key responsibilities of the owner organization as far as functional safety is concerned? Well, the owner organization needs to make sure that the feed study, part of the feed study is to look at, and again, if it's a green field versus a brown field, if it's a green field, then you need to make sure you do the right risk assessment. And this will then play into how the plant is laid out, where the hazardous materials are stored, how much hazardous material is installed, where are the people going to be, if we're going to have plant workers and office workers. And so all of that is usually done as part of what we call a QRA, a quantitative risk analysis. And there are companies that have specific tools, modeling tools for being able to do blast modeling, dispersion modeling, etc. I've seen FSA 3 done, but just covering paperwork and only covering control system, assuming the field instruments are installed properly. Shouldn't the FSA 3 validate as well if the field instrumentation specification and installation is in compliance with the SIL target? Well, of course, that should be part of. This is why when we do an FSA 3, what we should be looking for is there should be, number one, you should make sure that the timing is correct and that the instrumentation is as per the SRS. So if the SRS has been done and the SIL verification has been done, then there should be certified equipment in there, or if it's not, there should have been a proven in use justification performed. And we always look for, initially they should do a trip test, and then because the trip test will also look at the response times to make sure that the SIFs respond quickly enough in terms of process safety time. Now, process safety time has to be included in the SRS now. That's another change from 2016. So this is very important. And then to run through all the proof tests to make sure that the proof tests maintenance can run them, they're confident, and it may even find some problems at that stage. But certainly the field instrumentation needs to be looked at as part of the FSA 3, because they should be in the detailed design information as part of the SRS. In oil and gas industry, how can I get I'm not sure what that means, because it looks like the comment wasn't completed. How can I get experience in the validation phase if I am usually part of the design phase? Well, yeah, that's a problem because you're not independent. That's why we have the independence. Simple as that, is to make sure that it's not the same people doing that. Now, there's nothing wrong with you being part of the team, but you will not be responsible. You know, you might be consulted and ask questions, but you wouldn't be responsible for performing the FSA. So the only way there is to either change roles so that you're not part of the design team, or find another position where you can do that, I'm afraid. Well, all good questions. Any more questions? Well, I appreciate everyone taking part, and I appreciate the questions. These are good questions. Oh, we've got another one come up. Okay, let me just review these. Case studies, webinar on the gas and sub-study compliance with IEC. Okay, yeah, that's a good point. We have a product which already in the market from last 10 years without any failure. Do we have to follow same process for SIL approval for existing product? We have product which are already in the market. Yeah. Well, 1511 is very clear. You have two methods for justifying the use of equipment. One is to use IEC61511 certified equipment to the specific SIL level, or the second is to do a proven in use justification. So yes, you may have it for the last 10 years without any failure, but do you know you haven't had any failure? You might not have had any failures returned to the manufacturer, but there may have been failures in the field. So it really depends upon the quality of the field failure data and what information is available. If it's, as you say, there haven't been failures, then it should be fairly easy to do a proven in use justification. Are CFSE individuals considered fit for facilitating HAZOP workshop? It depends upon their background and experience. CFSE means that you've achieved a certain level of expertise and knowledge in regards to the standards and functional safety. But if you haven't been doing or haven't been facilitating HAZOPs, then that doesn't make you qualified to do that. You would need to have experience of doing that, and my advice for that is to sit in on some HAZOPs initially and then to jointly facilitate to get the experience. Because we have found in many cases that HAZOPs have not been done properly because the person facilitating thought they were qualified and experienced to do it, and in reality they weren't. We had one case where a HAZOP had been done and we came in to do the local study, and we found that they'd actually missed some significant scenarios during the HAZOP. So the point about HAZOP, or point about doing a PHA, is that you should really have your most experienced people involved as part of the team. But the problem is with most end user companies is that they can't afford to have their most experienced people offline for a number of days or even weeks. So what tends to happen in some cases, and again, this is not a total generalization, but it does happen, is that there might be one or possibly two experienced people and the rest are all made up of newbies. Guys that don't really understand the process that well, are fairly new to it or new to the equipment, in which case you are very reliant on the expertise and knowledge of the facilitator, because if he's not good enough, you could end up with the team going down rabbit holes or focusing on the wrong areas or getting bogged down where they don't need to be. So it's very important. Is fire and gas covered under 61511? Well, 1511 talks about CFCs being either protecting or mitigating. And of course, fire and gas comes under the latter. It's a mitigation system. And you can get certified gas and fire detectors now. Now, in that case, if we're looking at a safety instrumented function as being a mitigation function, then you can consider fire and gas if it's, for example, you're looking to, if you have a gas leak, you want to detect that gas leak as quickly as possible. You want to be able to shut off the supply of gas as soon as possible to minimize the potential for explosion if it happens to be a flammable gas. All right. Any more questions? Oh, another one. Does Exeter conduct any? Yes, we do. We have a 2-day HAZOP course, which is actually going on as I speak in the training center next to me. So we do have a 2-day HAZOP course. Anyone interested in the training, please feel free to contact our training coordinator, Miss Jitana Wasserman. She's always ready to help, and you can. And also, if you have any other further questions, you can always contact me. My email's below there. I'm always happy to answer any questions you have. It's not necessarily a certificate. Well, again, you see, we're using the word certification. The FSC 100 is a 4-day course that helps you prepare to take the CFSE or CFSP exam. The FSC 100 itself has a 1-hour FSP exam at the end of the course, which is a certificate. And the difference between certification and a certificate is based upon a course or a period of study of something. So you've studied something and you've taken an exam based upon that material. And with the FSC 100, we have the FSP, which is based upon the material covered during the FSC 100. The certification such as the CFSE or CFSP is far more than that. With CFSE, you have to show your knowledge and experience dealing with safety, because you have to submit a separate case study, and then you have ongoing requirements. So every 3 years you have to submit and show that you're maintaining, similarly to a PE, for example, or a chartered engineer in the UK, you have to maintain your level of knowledge and competency. The other thing is you can also go to www.exida.com and then go to the training tab to also see what's going on. I think Jitana's just sent that message out if you haven't seen it. So use the website, exida.com website. We have all the courses covered there. Any questions, like I said, you can contact Jitana or myself and we'd be very happy to help you. Any further questions? Well, with that then, I thank you all very much for your attendance. And like I said, if you have any more, let me know. There are my emails below, and I'll be happy to answer those. So enjoy the rest of your day, or good night, or good morning, whichever where you are. And I look forward to you being on another webinar. Thanks a lot.